Hello, MYP students. Today I would like to take you through investigative skills, basically Criterion B, which talks about inquiring and designing. Today we shall be focusing mainly on the inquiring part. There are skills we expect you to develop, which will help you to develop your inquiring skills. When questions are said, some questions will be familiar to you, but some may be unfamiliar to you, but it doesn't matter. What matters is how to develop the inquiring skills. If you know and you have those skills, you'll be able to answer any question that they will be asking you. So let me take you through what you need. The very first thing you need, a very good scientist who is an inquirer must be able to identify the variables. You must be able to identify the variables. As you're well aware, variables are factors that can change within an experiment. Every time you want to investigate something, there are factors you are looking at. And those factors are three of them. There are three types of variables or factors. Could you please name them for me? Yes, that's right. One of them is the independent variable. That's very good from you. The other one is the dependent variable. Then the last one are what we call the control variables. So the things you need to know as an inquirer, you need to know how to identify these variables within an experiment. Now, all these factors and variables, they can be found in the stem of the question. Normally, when a question is starting, they begin like with a story. There are so many words in there, and we tend to skip them and you go straight to the question. That's not right. Please read the stem carefully. As you are reading it, you begin to picture an idea of what they are trying to look out for. Therefore, it's very important that you read the stem. Also, the variables could come from what we call the research question or the research statement. We shall be seeing this shortly as we move on. It can either be a research question or it can be a statement. Yeah. So, like they taught you, an independent variable, that will be the factor which is affecting. It's the one you want to find out its effect if you change it. So normally, this factor is varied by the experimenter. For example, if you want to find out the effect of temperature on rate of diffusion, then you will have to use tea leaves and put them in different water at different temperature. Because the temperature is being varied, that becomes your independent variable. Yes, always there. Then, what you measure at the end of the experiment, your outcome is the dependent variable. The word is measured. It must be measured. For example, I said, investigating the effect of temperature on rate of diffusion. It's true, when someone looks at this, temperature is affecting rate, meaning rate depends on temperature. However, in an exam, you cannot say rate of diffusion. You will be wrong because rate cannot be measured. Rather, rate is calculated. You have to put it in values and calculate it. So it is something you must measure. If I were to find out how temperature is affecting diffusion of tea leaves, what I will actually measure would be how long it takes for the color of water to turn into the color of the tea leaves, maybe brown. So time becomes the dependent variable. Always be very careful. When examiners said, for them they use the word rate of diffusion or something, rate. But between the lines there, the word I want you to say must always be there. So be careful, never say rate. Rate is wrong, but the word is what exactly are you measuring within the experiment. Yeah. Then variable simply means if you want to find out how temperature is affecting rate of diffusion, then ask yourself, are there other factors which can affect the rate of diffusion? And meaning you must keep them constant. You must maintain them for all the experiments. Because if you change them, they will also change your experiment. For example, you're looking at how temperature is affecting rate of diffusion. You'll be using water at different temperature. So what you must keep the same are things like the amount of water. So this becomes controlled because if we use different amounts of water, it could affect your results. Therefore, what you are investigating would be wrong. You must keep the amount of water the same. Could you guess what else could we keep the same in our experiment of investigating effect of temperature on diffusion? Yes, that is correct. You can also talk about the nature of the cup you are using or the vessel or the beaker. Because if you use a plastic one, they are non-conductors. If you use a metallic one, they are conductors. So even that can affect your results. So you must use the same nature of a vessel you are using for experiment. If they are tea leaves you are using or food color, they should all be of the same type because different types can have different concentration. That's so important. If you are putting in tea bags, you must be putting on the same number of tea bags. So even the word number of tea bags is important. Yeah. The only thing I want to caution you on listing the control variables, well, it's okay. So amount of water can be there, the number of tea bags, type of the tea bags, and etc. So these are very important. Let's try out a few questions so we can identify the different variables and we see how it all goes. All right. Um, Let me remove this. Hope you have written them down in your books. If I move to page 19, right here, the question says, a scientist investigating teeth and bones developed the following research statement. As I said, variables can be gotten from a research statement, can be gotten from the stem. The stem would mean these questions here that I mentioned before the experiment, these ones here. Shall even go back there and check on them later. So right here, they are saying that the higher the percentage of calcium carbonate in the bones or teeth, the larger the volume of carbon dioxide produced. So, when we now identify the independent variable from a research statement, what you do is simple. Normally, when writing them even, the first factor they talk about is the independent variable. And the second factor they mention becomes the dependent variable. That is how it's written. Could you guess what could be our independent variable in this case? Yes, that's right. It's the percentage of calcium carbonates. That's the independent variable. Then they're asking us identify the dependent variable. Could you guess that one? Oh yeah, that's perfect. It's the volume of carbon dioxide produced. So you see, from a research statement or research question, you can easily see them. They are always there. And now when you're writing them, the independent comes first and the dependent comes next. So that becomes easy for you to tell. Then the other question they are going to ask us is to mention the control variables. Now, this one, you can't see it in a research statement or question. The stem must be read so you understand. So we shall go back up here and check and read it. They are saying bones and teeth from different animals contain different amounts of calcium carbonate. Okay. Many animals are at a risk of extinction because of illegal trading of their teeth and bones. Scientists, I'm looking something. Scientists can use calcium carbonate data to identify which animal's bone sample came from and check that the bones are not being traded illegally. So scientists are saying us that each animal has a given amount of calcium in their bones. If you get a dog, all dogs have a not really okay, it's a close answer, a similar answer of calcium carbonate. They are here. The elephant, doesn't matter which elephant you get, you always have 20.9993% of calcium carbonate. So if you investigate and you find out that your value is 20.9, then you will know that is an elephant. Now, with that idea in mind, keep reading. Metal carbonates react with hydrochloric acid to form a metal chloride, water, and a gas which turns lime water cloudy. Okay, they are here. Now, in this experiment, try to find out, they are saying the more calcium carbonate you have, the more carbon dioxide you produce. So ask yourself, what could be the controlled variables here? If you want to find out which bone is from a dog, which bone is from a donkey, which bone is from a dolphin, what must you keep the same? That's a good guess. That's true. That means that you must obtain bones or teeth from different animals like these ones here. However, you must be using the same amount of the elephant's bone, the horse's bone, the human's bone. If you use different amounts, then they will have different quantities. So you must use the same amounts. Now, amounts not a good word to say, but these are masses. So the same mass of calcium carbonate. That's okay. And they said they were reacting it with an acid here. Therefore, that would imply that the controlled variable becomes the amount of acid. You can't get controlled variables if you don't read the stem. You have to go back there and read carefully, understand. When you understand, now you can write down the controlled variables. That's the first part of the inquiring part, being able to handle variables, identifying them. Then the second part of criterion B talks about, do you know how to write a research question? They will always ask you to write a research question. But do you know how to write one? In some questions given to you, but in some you write your own. Now, what matters in a research question, you simply want to find out. You simply make a statement, which is a question. Does watching football at night affect your concentration in the morning? If you watched Arsenal till midnight, till 1, does it affect what time you woke up today? That becomes a research question. So two key things are key. One, always indicate the independence and the dependent. You must always, in your research question, indicate the independent and as well your dependent variable. They must be there within your research question. And as I told you, normally independent comes first and dependent comes next. There is no formula on how it should look like. As long as those factors are well related, you'll be good to go. Let me show you an example. Let's try out this together. It also calls for reading the stem. Without reading the stem, you are going nowhere. All right, we have a number here. Question 6. It says, design, make it bigger for us to see it well. Design a way of simulating acid rain formation by sulfur pollutants and investigate the effects of these pollutants on the pH of water. Now we go down. They tell you, propose a research question for your investigation. Now, for such a question, you have to go back, read patiently, and identify what is affecting what. What is depending on what? Could you guess? Which answers could they be? Which one here could be dependent? Wow, that's very good. It's the pH of water. This pH of water here is depending on the pollutant. Now you know the answer. pH of water is dependent. pH of water becomes dependent. Investigate the effects of this pollutant. Now, this pollutant is what? Sulfur pollutants. So, sulfur pollutants becomes the independent. It's the one affecting your dependent variable. Now, phrase anything. Ask yourself a question. As long as those two things come out, you'll be good to go. Normally, you begin with how. Someone can say, how does sulfur pollutants affect the pH of water? You see, it's a question which you can go out and investigate. How does the sulfur pollutants? Someone can even make it better. How does the concentration of sulfur pollutants affect pH of water? Someone can even say, how do different types of sulfur pollutants affect pH of water? As long as sulfur pollutant is there, tick. Pollutant is there, tick. Normally they give it 2 marks. Now, depending on the year, if you mentioned one variable well, if the variables are there but not well written, you get 1 mark out of 2. But why do you want that? Make sure you get them very well. How does sulfur pollutants affect the pH of water? Full stop. Question, not a question mark. And you're good to go. That's called a research question. But sometimes they give you research questions or research statements. Like we saw in this previous number, the other one wasn't a research question, rather it was a research statement. If you look at this, it was down right here. The higher the percentage of calcium carbonate in the bonds, the larger the volume. Now, this isn't a question, but a statement. They can even ask you to make a research statement. So if we go back to our previous question, can you think about a research statement? Could you phrase one? So it's not a predictive statement. You are saying maybe the higher the concentration of sulfur pollutants, the higher the pH of water. That's okay. So it's a statement you make. You predict something, but it's a statement. It is simply a statement. Yeah. So today I've taught you Criterion B, which is inquiring skills. It has 5 things in it. So far, we have learned the variables, learned about how to write a research question and a research statement. Lastly, for today, I will teach you how to evaluate. Normally, they can give you a statement and they say, evaluate it. Evaluate means that is it right or it's wrong, basing on the data they have given you. That data normally is in a table or it can be in a graph form. And they will ask you to evaluate, to make a statement, whether it's right or it is wrong. Let's look at an example. Right here. Yeah, this could work for us. Let me confirm that it has what I need. We'd like to evaluate one together and we see how it goes about. Perfect, perfect. They are saying the table below shows some data about the composition of different nappy brands. We all know nappies. Normally, babies put them on, maybe to for example, you're moving with them on the roadside or they are sleeping to avoid them peeing on the bed. We give them nappies. There are different nappy brands, soft care and etc. Now, we are being given the nappies here. Read carefully. Now they're saying nappy composition, what they are made up of. Some have pugs, some have humps, little angels, little ones, quick cuties. such things. As I told you, the questions may be familiar or unfamiliar. What matters is the skill you develop. The thing, pluff here, hydrogel, total mass of the pluff, water absorbed by hydrogel, natural absorption, etc. Now, one of the students came up with the following research statement. The more hydrogel in nappies, the more absorbent they are. Hey, is that true or that is false? That the more hydrogel in nappies, so now you can look for the word hydrogel. Hydrogel is right here. So look at the amount of hydrogel in each of them. The amounts are there, here, amounts are here, amounts are here, amounts are here, amounts are here. Okay? Now they're saying that the more hydrogel you have, the more water you absorb. It's water or urine. Well, the more liquid you absorb. Okay, is that true? So what you do, you will compare this statement here and NAPI's total absorption. Observe carefully. So let's begin by observing hydrogel. Where do we have the highest value? You come and check the highest value is right here. The cuties. So the question is, are the cuties the ones having the highest amount of water absorbed? Its value is at 197. Let's look for another one, which is slightly lower than the cutie value. This is 5.4, 3.9. Okay, if we look at it, this one has less hydrogel. If you compare its value, validity-wise, you see that when you have less of it, it's true. This value is also lower, okay? That trend is there. Let's look for another one. Let's go to where we have 3.56. Now, when you come here, when you use a different color, when you come here, a problem arises. The value you get is meant to become lower, but now it is higher. When you see a red flag there and then put a star. So now we go back and read. When they say validity or evaluate, we are asking, tell us whether it is true with the reason from the table, whether it's wrong with the reason from the table. Some questions are both right and wrong. But generally, okay, evaluating means that you are defending something at the same time critiquing it. So someone could say, in one way, the statement is valid because in cuties, which have a higher hydrogel mass than the humps, we said they have a higher total absorption than the hydrogel. Okay, that's true. However, the little angels that have a lower hydrogel have a higher water absorption, water or urine, than the nappies. With all this now understood, let us make now the final decision. Are we rejecting it or we accepting it? Finally. That's right. We are rejecting the statement. The statement is fully wrong. The more hydrogel nappies, the more absorbent they are. So the best answer we shall give here, the answer is wrong. The statement is not valid. It's not true. Then you back it up with the reason from the table. Little angels have a higher hydrogel, lower hydrogel, yet they have a higher absorption than the hubs. Or you can compare with anything else and you'll be good to go. So I've taught you also a skill of how to validate or how to evaluate. It means you read a question and you decide whether it is correct and you defend it with a reason from the table or the graph, or you reject it with the reason. For this example, we have rejected it because of a reason. Thank you for listening to me. I was glad to have you. In the link below, I've attached a Google form. Please go there and try out these questions, and I'll give you feedback as soon as you're done. Have a good day.